Good afternoon. Great. Well, welcome to AI Week. And this is the very first event that we are hosting with the Office of Provost. We have four keynote speakers who will be presenting along with panel discussion tomorrow afternoon. And then all throughout tomorrow and Wednesday, we have events throughout the days that you can participate in discussion of AI, what it means, what are its limitations, what's potential, and what kind of effect that it will have for us at universities and beyond. And for students, what will happen to you as you're learning, as well as after you graduate in your career. So we're very delighted to start this series with Dr. Robert Marks. And I was just sitting down with him and telling him that we're so lucky here at Baylor that we don't have to go outside to get a great world-renowned speaker as Dr. Marks is. Just give a brief introduction of Dr. Marks. He is a distinguished professor of electrical and computer engineering here at Baylor University. And he's a senior fellow and director of Bradley Center for Neural and Artificial Intelligence at Discovery Institute. Dr. Marks is a fellow, which is the highest recognition you can get in your professional societies, of both the Institute of Electrical and Electronic Engineers and Optica, which is also known as Optical Society of America. He was the former editor-in-chief of IEEE Transactions on Neural Networks. And neural networks, as many of you know, is the basis of all the machine learning as well as the generative AI platforms. Dr. Marks was also president of IEEE Neural Networks Council, and now it's called IEEE Computational Intelligence Society. So we're so lucky to have him today. We look forward to hearing about what he has to say about ethical AI and non-computable you, what you do AI never will do. So Dr. Marks.
That was a very nice introduction, especially about my reputation. He didn't mention how I responded. I said, I don't deserve an introduction like that, but I also have lower back pain and I don't deserve that either. So I'm going to take his introduction and I'm going to do it very, very nicely. So I was in court the other day, not as a defendant, not as a plaintiff, but as an observer. And one of the things I'm interested in as an engineer is seeing AI reduced to practice. And so I looked at, what do they call those people that go doop, 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 and they do the whole transcript? Is that a court reporter or the stenographer? Anyway, I talked to her, and they don't use that anymore. They use voice recognition, and she uses large language models. She uses something like ChatGPT. It's being used there. I thought this is kind of cool. So if she had something which is ambiguous, and it turns out that these large language models can actually resolve things that are ambiguous. It's really interesting. There's flubbed headlines like, hospital sued by 7-foot doctors. Think about that a little bit. That can be taken two ways, right? Either there were 7 doctors and there were podiatrists, or they were very tall doctors suing the hospital. So if there was an ambiguity there in the transcript, the software that this stenographer was using would correct it. So I came up with an example. I thought that since we're the Baylor Bears, there's this great homonym, and it's a Christian, it's a Baptist. If you're a Baptist, you know it. Gladly the cross-eyed bear. But also gladly the cross-eyed bear could refer to a bear that was cross-eyed named Glad Lee. So maybe we should have a mascot called Gladly the Cross-Eyed Bear. Wouldn't that be nice? And to have it as a habitat here. So I wanted to talk about a bunch of stuff. My purpose of my talk is kind of push back against some of the hype that's associated with artificial intelligence. And most of the talks today are going to be what I think AI is going to do. It's going to be used as a tool. And it is going to be disruptive, but it's also in general going to make our lives a lot easier. So there's a lot of people that disagree with me. One is Ray Kurzweil. He wrote a book called The Singularity is Near. He wrote it 20 years ago. And what is the singularity? The singularity is where AI begins to duplicate the abilities of human beings. And then if AI gets stronger and stronger and stronger, pretty soon it will become really super duper intelligent. And that was 20 years ago. Another one was Yuval Noah Harari wrote a book called Homo Deus. And he believed that evolution has come to an end. So did Kurzweil. Evolution has come to an end, if you're into evolution, and we have reached everything that we can in terms of evolving of people. And he said, now we have to hand over that evolution to silicon. We have to hand it over to the computers. And his book was Homo Deus, and this is the evolutionary track. You had Homo erectus, Homo sapien, Homo Deus, Deus meaning God. So this is going to be a kind of a godlike entity. Now, the singularity is near. This was written 20 years ago, and you know what? It didn't happen. A lot of Ray Kurzweil's things didn't happen. So last year he wrote another book called The Singularity is Nearer. So we're getting closer and closer to it. Maybe in 20 years, we'll get another book by Kurzweil, and this is just around the corner. So this is interesting. So one of the things that happens about AI that you see all over the place is that artificial intelligence is, it's hyped. It's hyped all over the place. And in some of the places that it's hyped, it's very scary. Let me give you an example. This is an article from the New York Times. A new Navy device learns by doing. Psychologists showed embryo of computer designed to read and grow wiser, and the Navy revealed an embryo of an electronic computer today that it expects to be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. This is the type of headline that we see today. You know when this was published? July 8th, 1958. So this is a headline from 1958. And we see these hype sort of things happening way in the 50s. We see them, I've seen them my whole life, and I've lived a long time. And we see that these hypes occur a lot. And there's some people that fuel this. These are people that I say are kind of like Chicken Littles. And these are pretty smart people. We have people like Bill Gates. He says, I don't understand why some people are not concerned. Stephen Hawking said, the development of full artificial intelligence could spell the end of the human race. Whoa, I mean, this is kind of the Homo Deus sort of thing, very dystopian future. It would take off on its own and redesign itself at an ever-increasing rate. Humans who are limited by slow biological evolution couldn't compare and would be superseded. Now, there's an assumption here, and that assumption is that AI can write better AI, can write better AI, can write better AI. And we're going to address that very soon. Even Elon Musk, who I have a great respect for, said, with artificial intelligence, we are summoning the demon. George Gilder, the founder of Discovery Institute, said, Elon Musk is an incredible entrepreneur, but he's kind of a retarded thinker. And one of the things that he pointed out was, for example, Elon Musk believes that we are simulations. Did you know that? That we are simulations and living in a sim world. And so he has some crazy ideas. And I don't know if you follow the news, but last week, the Nobel Prize was awarded in physics to two researchers in neural networks. Those two researchers were John Hopfield at Princeton University, and this guy. He doesn't deserve the prize, and if you want to talk to me later, I can tell you why, but he's the 2024 Nobel Prize in Physics. I have no idea what this guy did that relates to physics at all, but this is what he won, the 2024 prize in physics. And Jeffrey Hinton from the University of Toronto said, I'm worried that the overall consequence of this might be systems more intelligent than us that eventually take control. This is the hype, this is the fear that we have. This statement was made only last week. Now there's people that believe otherwise. And a person that would influence me a lot is another Nobel Prize winner. This guy won the Nobel Prize in 2020. He worked with Stephen Hawking, and he would have been awarded the Nobel Prize with Stephen Hawking had indeed Stephen Hawking been alive. You have to be alive in order to get the Nobel Prize. And this guy is a British guy named Roger Penrose. He won the 2020 Nobel Prize in Physics for the singularity theorem, roughly as I understand it, black holes. And he wrote this incredible book called The Emperor's New Mind, which showed that we have attributes, that humans have attributes that cannot be performed by computers. And that's what I want to go through. I want to talk about the things that we do that computers indeed will never do. One of the things is we can create beyond our foundational experience. Now, if you dig through this volume, you'll find lots of mathematics. So you really have to be a nerd in order to break through Penrose's work. So what I did, I was so impressed by him, I wrote a book which kind of brought this down and tried to explain it at a more lay level in the book Non-Computable You, What You Do That Artificial Intelligence Never Will. So it's interesting that we have Penrose, another Nobel Prize winner, who says that no, AI is not going to duplicate what we do, in contrast to his colleague Stephen Hawking, who said he's really afraid of what's going to happen. So here is kind of the outline of my talk. I'm going to talk about the idea that computers will be amazing, but they will never be creative. Now we have to be careful here, because a lot of people say I can't be creative, and then people start arguing before they define what creativity is. So we need to define creativity before we talk about whether AI is going to be creative. It will never understand what it does. Computers today can add the numbers 14 and 12, but it doesn't understand what the numbers 14 and 12 are. So it will have no understanding, and we'll dig deeper into that and the reasons for that. It will never be sentient. It'll never experience qualia. It'll never achieve anything like the singularity that Kurzweil is a proponent of, and it will always be hyped, as we saw in that 1958 article from the New York Times. So it's always going to be around, it's always going to be hyped, and it's scary. One of the reasons that Penrose points out is why? Why is this true? And one of the reasons he says is because of, drum roll, I can do this, algorithms. Now it's hard to know the audience that I have, so I'm going to go with a little bit of background on what an algorithm is, in case you're a political science major. I'm sorry, I hurt somebody's feelings. Well, yeah, okay, let me go on. So here's an algorithm. An algorithm is nothing more than a recipe, a set of rules to be followed in problem-solving operations. You should know my son graduated with a bachelor's degree in political science, so I hold political science to be in the highest of realms. An algorithm is a recipe. It is a set of rules to be followed in problem-solving operations. Here's an example. It's on the back of your shampoo bottle. Wet your hair, apply shampoo, lather, rinse, repeat. So that's an algorithm. It's a step-by-step procedure on how to wash your hair. Can anybody tell me why this algorithm is flawed? Okay, all of the engineering students, why is it flawed? You don't have an end. You repeat. And so therefore, if you follow this algorithm, literally you would be washing your hair forever. Okay, so it's a bad algorithm. Another example of an algorithm is a recipe. All recipes are nothing more than algorithms. If you bake a cake, for example, it tells you the step-by-step procedure in order to bake a cake. Algorithms are a step-by-step procedure for doing things. Google Maps. I love Google Maps. Google Maps gives you an algorithm on how to get from point A to point B. You drive down the road 2 miles, you go to the gas station, you make a right, you go to New Road, take a left, and there's your destination on the left. It's a step-by-step procedure from getting from point A to point B. That is also an example of an algorithm, step-by-step procedures. Well, it does turn out that all computer programs follow algorithms, and if you've ever written a computer program, you know that it is a step-by-step procedure. As a matter of fact, if you go even to a website, This is Mind Matters. This is the website of the Bradley Center. And you right-click and you say, show source, you'll get some code on the right. This is the algorithm, this is the code that is being used to generate that image or to generate that web page. So everything is an algorithm. In fact, even AI and all of the AI today is run by algorithms. Probably the most famous of which is error backpropagation. Error backpropagation is used to train generative AI, it's used to train transformers, it's trained to use anything to do with neural networks, and it's an algorithm. So it's a step-by-step procedure. So there's nothing magic about the AI. Now here's something interesting. If you think about different fields other than computer science, there are certain brick walls that certain fields will never break through. For example, in physics, you can't exceed the speed of light. If you go close to the speed of light, you get an infinite mass, and that's a bummer. You can't go back in time. The patent office refuses to do any patents having to do with perpetual motion machines. This is a wall that physics will never break through. We have in mathematics, if you've ever tried in mathematics to trisect an angle with a straight edge and a compass, you can't do it. And then there's Gödel's theorem, and that's a whole other lecture. That's just astonishing stuff. Are there brick walls in computer science? And the answer is yes. We are restricted to things which are algorithmic. And because of this restriction of algorithmic, we have some restrictions. That's something that computers will never do. They will always do algorithms. Now, you might think that this is hand-waving, and if you think about algorithms, you kind of think everything that you think of has an algorithm associated with it, right? But it doesn't. There are things which are non-algorithmic. In fact, this was proven by the father of computer science, Alan Turing, back in the 1930s. He proved that you couldn't generate a computer program to say whether another computer program would halt or run forever. It's called Turing's halting problem. If you took that shampoo bottle, for example, and you plugged it into this Turing machine, or this Turing halting oracle, which doesn't exist, it would say this algorithm loops forever. However, if you have other programs, you plug it in and it will say this algorithm is going to halt. So that's the idea. You present it with any computer program, and the Turing halting oracle would say that will either halt or that will run forever. So that was the problem that Turing considered back in the 1930s. And it was the first case of proving something was non-algorithmic. He proved, this isn't conjecture, he proved mathematically that this was an impossible task for computers to solve. So there are non-algorithmic things which do exist in the world. Another thing which is non-algorithmic, very interestingly, oh, by the way, this has to be any computer program. There's clearly computer programs, if the first line is halt, yeah, that's going to stop, right? There's the shampoo, yeah, that loops forever. But this has to work for any computer program, and Turing showed that that didn't work. Gregory Chaitin, who is one of the fathers of algorithmic information theory, also proved something else. And by the way, since Turing's proof, there have been a lot of things which have been proven to be non-algorithmic. Here's another one. Say I ask you to sit down and I ask you to write code that generates the number pi to 20 significant figures, okay? I think a lot of us who have experience in computer programming could do that. So you write a program to compute pi to 20 significant figures. I write a program to generate pi to 20 significant figures. One of our programs is going to be larger than the other one, right? The question is, well, this leads to the conclusion that, okay, is there a shorter program? If there's a shorter program, there is a shortest program to generate the number pi. It turns out that identifying a program that cannot be reduced in size anymore is also non-algorithmic. So there are things which are indisputably non-algorithmic. So this leads to the question, if there are non-algorithmic things in computer science, are there non-algorithmic things associated with our character and who we are? And that's the question I want to address. Kurzweil and Yuval Harari The authors that I talked about before assume that no, that isn't the case. Their assumption, by the way, is that we are computers, you and I are computers made out of meat. And therefore, if we're computers made out of meat, we should be able to take whatever that computer is that's made out of meat and duplicate it in silicon. It's actually a pretty bold assumption. It's a materialistic assumption, and it's a wrong assumption, as we'll see. So these I'm going to maintain, go through them one at a time. These are non-computable human attributes. Number one is qualia, and this is more of an argument than a proof. I'm going to talk about sentience. Qualia is a type of sentience. And if you're like me, I didn't know what qualia meant until about a year ago. Okay, it's a new word to me. Might be a new word to you too. I don't know. Understanding, computers will never understand. I'll give you an argument for that. I think some things are obvious. Computers will never have emotions. They will never love. They will never have empathy, etc. Creativity, and again, computers will never be creative. And consciousness. We won't go into consciousness because in order to go into consciousness, you have to define what consciousness is. And I don't know anybody that has a consensus on the definition of consciousness. It turns out people talk about it all the time, but everybody has their own self-definition. Okay, there's some very interesting implications of this. And one of them is the implications for uploading yourself. You've heard about, by the way, this is a religion, okay? Christianity teaches about immortality. Computer science teaches immortality because we can upload ourselves. We can upload ourselves in the cloud and we can live forever. But the problem is if we are non-computable, the only aspect of us that can be uploaded is going to be the algorithmic part. And I maintain without the algorithmic part, we're going to be pretty boring in a computer simulation if we remove all of these things. So let me talk about qualia. Qualia is an experience that you have, a sensual experience, like biting into a lemon. If you cut yourself, you feel the pain. Let's talk about biting into a lemon, because that's more fun than cutting yourself. So this girl is biting a lemon. When you bite into a lemon, you feel the juice pop in your mouth, it goes on your tongue, you feel this terrible sense of sourness, and you have an experience. Now, imagine explaining this experience that you had to a person who has been void of the senses of smell and taste since birth. This person has never tasted anything. They have never smelled anything. And you go up to them and said, yeah, this lemon is sour. They have no idea what you mean. You can explain them the chemistry of the lemon. You can explain them the biology of taste buds. You can go through all of that. But you will never be able to explain to that person exactly what you experienced in terms of qualia in tasting that lemon. And so the question is, if you can't explain it to a person that has been void of the sense of smell and taste since birth, how are you going to write a computer program to do that? There are some people and some computer scientists that say, well, as we get more complex and more complex, that these things will emerge. There's absolutely no evidence of that. George Gilder, one of the founders, I quoted him before, but he calls this the idea that we're going to get all of these senses by getting more and more complicated. He calls this rapture of the nerds. And it is something which is simply not going to happen. So there is no sentience in artificial intelligence. Here's another one. So we're going to go through them just one at a time and touch on them. If you want more in depth, you got to buy my book. And buy it new, okay? So I get royalties, okay? Another one is understanding. Now, understanding is really paramount. And this argument was made, I believe, 40 years ago by John Searle, who was a philosopher. And his premise was that, no, computers don't understand. And he came up with something called Searle's Chinese room. And in Searle's Chinese room, why did he choose Chinese? Because he couldn't speak Chinese, he didn't read Chinese, he didn't understand Chinese, so he wanted to choose a language that he knew nothing about. So here's the situation. He's in a room with a bunch of file cabinets. When he did this, they had file cabinets. I think maybe a lot of our students don't even know what file cabinets are today, but he had a bunch of file cabinets in this room. And somebody came up and they slipped under the door, through a little slot in the door, into the Chinese room to John Searle in the Chinese room, a question which was written in Chinese, like we have here. Anybody read this Chinese? What is it? It's John 3:16. So this is John 3:16 in Chinese. So somebody might say, is John 3:16 true? Or ask him some other question. Well, here's what Searle did. He had all these file cabinets. So he took the Chinese slip of paper and he looked at it and he started to go through the file cabinets until he found a match. And in the file cabinets was the answer to the question. And so Searle would pull out the answer to the question. The question was also written in Chinese, and he would copy this down. He had no idea what it meant. He would refile the card. He would go over to the slot in the door and slip the answer out. Those contents of the file cabinet were put there by a programmer somewhere. And he would slip it out, and the person on the outside would go, wow, he answered the question. Whatever is inside this room must understand Chinese, must know what Chinese is, because otherwise they wouldn't be able to answer the question. And of course, that's not true. Searle doesn't know Chinese. He doesn't speak Chinese. He doesn't read it, write it. What did he do? He was following an algorithm. He was following a search algorithm to do that. Now, when Searle made this was many years ago, I believe in the 1980s, things were a lot simpler then. The things we do with computer programs are much more complicated than lookup tables, if you will. Currently, we have transformer models like large language models and ChatGPT, but the same thing happens. You slip your query through the door, it's put in this big mechanical algorithmic machine, out spits an answer, that answer is slipped through the door, the ChatGPT response, for example, and you go, wow, ChatGPT is smart. No, it doesn't understand what it's doing. It's following an algorithm. So computers in general, and AI specifically, are unable to understand what they do. And I think Searle's Chinese room, I have the date here, made in 1980, was actually a smackdown, which a lot of people don't think about today, but I think it's kind of obvious. Again, there's this appeal to the rapture of the nerds, but that isn't going to happen. Some of you remember IBM Watson being the challenge in the game Jeopardy. And if you remember that, Jeopardy is where you're asked questions and then you get quick responses. And Watson, the IBM computer, was in the contest, and it won the contest. Did it understand anything that it was doing? No, it had a humongous Chinese room. Its Chinese room included all of Wikipedia, everything on the web, and that took the place of the file cabinets. So did it have any understanding of the response that was giving? Absolutely not. It was following an algorithm. So therefore, no qualia, no understanding. Let's talk about creativity. And I want to define creativity. And creativity was wonderfully defined by a colleague of mine, Summer Bringshaw at Rensselaer Polytechnic. And it's called the Lovelace test. Ada Lovelace, by the way, was the first computer program of the 19th century. She worked on Babbage's mechanical computer and really had a lot of insight into computers, which survives today. So Ada Lovelace, her picture is on the right here. He named it after Ada Lovelace because Ada Lovelace says computers will never do anything creative. So hence the name. So Summer Bringshaw said AGI will be artificial general intelligence, which is the idea that AGI, well, artificial intelligence in general will be demonstrated. Creativity will be demonstrated when a machine's performance is beyond the intent or explanation of its creator. We will have creativity if that computer program does something beyond the intent or the explanation of the computer programmer. And that's the definition of AI. Now, you will notice this idea that AI is going to write better AI has the assumption that the first AI is going to be creative and is going to generate a new type of AI which was beyond the intent or the explanation of the first programmer. That's never been demonstrated. All of these transformer models like ChatGPT are doing exactly what the programmers intended them to do. Generative AI does exactly what the programmers intended it to do. So therefore, with this definition, the Lovelace test, you're not going to have creativity. And no, we have nobody who has passed the Lovelace test as of yet. There was an interesting paper, Assuming Creativity, about AI writing better AI, published last year. And they called it Model Collapse. It was about model collapse. And they wondered, what about AI writing better AI? This is not a proof, but I think it's very nice evidence. What if you took something like ChatGPT and you trained it very well, and then you use that ChatGPT to train another ChatGPT, another large language model, using only the output from the first one? Does that make sense? And then you use that second generation to generate the third generation. So what do you think would happen? The more you think about it, the more it's obvious. They didn't use ChatGPT. They trained their own large language models like ChatGPT, and they trained it on architecture. And their first response was to a question about architecture, and the response was very good. Revival architecture, such as St. John's Cathedral in London, the earliest surviving example of perpendicular revival architecture, I have no idea what that meant, is found in the 18th century, Church of Our Lady in Guernsey. So it was doing what it was supposed to do. Well, they used that large language model, that ChatGPT equivalent, if you will, to train another model, to train another model, to train another model, to train another model. This is a quote from the paper, by the way. After the 9th generation, the AI that was trained using 9 generations came out and said, architecture, in addition to being home to some of the world's largest populations of black-tailed jackrabbits, white-tailed jackrabbits, blue-tailed jackrabbits, red-tailed jackrabbits, yellow-tailed jackrabbits, it became a blubbering idiot after 9 generations. So in this case, using a large language model to train another one, to train another one, to train another one, degraded. It's like the game of telephone you used to play. Remember, a bunch of people in a room and you whispered something in somebody's ear and they heard it and they whispered it to somebody else. And after about 10 people, you got the response, and typically it was a little bit removed from what was initially there. That's an example of model collapse. Here's another one. This is, again, is evidence, but it's very interesting. Okay, I don't want to, okay, let's see, AGI, your name here, okay. This was done by a guy on Twitter, X, if you will. And what he did is he used ChatGPT to describe an image. You can give an image to a version of ChatGPT and it'll give you a description of the image. Then you could give the description to an image to another AI program called DALL-E, and it will generate the image. You get the idea? And then we're going to take that image and we're going to ask it to describe the image. Then we're going to generate the image. And we're going to do that over and over and over again. Do you think it gets any better or it gets interesting? Let's see. Here's what happens. This is Mona Lisa. So it said, describe this image, et cetera, et cetera. So this is just fascinating. Ready? Oh, yeah, don't do it. What do you think? Anything creative or new? No, there was a degradation. This is the reason that the people called this model collapse. The model actually collapsed when you tried to use one AI to train the next generation of AI. Again, this is not a proof, but I think it's very interesting evidence that this is not going to happen, that this AI writing better AI is not going to happen. Okay, let's talk about the most it turns out a lot of stuff is going on with AI. Let me give you a brief description of what is going on with AI right now. We have generative AI, and this generative AI basically takes a bunch of faces. If you want to go to an interesting site, go to a website called thisfacedoesnotexist.com. Anybody gone to that? Okay, and you click on it and you get faces that are just realistic. What's happening there? Well, initially they took a bunch of real faces, and you can see these faces on the left. And these faces on the left were used to capture a part of the space in the space of all images where faces exist. And so you got enough of these to define what that space is. And then you can come along once you define what that space is, and using their algorithm, you can actually look at elements close in this space, and you'll get similar sort of objects. So that's a very high level explanation of generative AI, and it's really kind of cool. So I'm going to ask you which is real and which is not. Are you ready? This is from thispersondoesnotexist.com. Whoop. I gave you the answer. Okay. Anybody see somebody familiar there? Huh? Bottom right was Dean Pack. I gave away that he's real. Okay. 4 of these are real, 4 of them are fake. 4 of these are from the website, This Person Does Not Exist. And if the audience was smaller, I would point out which ones are real and which ones are not. Anybody want to try? Tom, you're wrinkling your brow. Any idea? Okay. Well, this is it. The 4 on the left are fake, and the 4 on the right are real. Those are real people. So again, it's indistinguishable. But if you click on, this is kind of interesting. It turns out the more complicated, I wrote a paper with a Baylor honor school student who I convinced to come on, get a PhD in engineering. And we showed he did a great job. He showed that as the complexity of a system increases linearly, the number of possible outcomes grows exponentially. It's actually kind of intuitive. But the idea is if you have a lot of moving parts in a model, the more ways it could operate, and usually the more ways that it could go wrong. Now, this generative AI has a lot of different ways that it could go wrong. And if you click on this enough, you get interesting results. You get these big fleshy blobs on the left, okay? So do I think that this can be, do you see the fleshy blobs? It's kind of spooky in a way. Can this be fixed? Yeah, I think it can be fixed, but this is what they have currently. And this is what's happening to all of these large language models. They're coming out with all sorts of things that don't work, so they're going in and they're putting Band-Aids on it to fix it. And you've seen changes in ChatGPT, which has become incredible. And one of the reasons is because they keep putting Band-Aids on it as the faults are pointed out. Here is one of my favorite generated pictures from generative AI. It's a picture of Christ taking a selfie of him and his apostles. Isn't that cool? Yeah, the answer is yes. Yeah, it's kind of cool. I don't know, I look at that and I think some people would think it's sacrilegious. I think it's really nice. So that's generative AI. What does large language models? These are transformers. There's a transformer model. A special case of the transformer model is the large language model, which is used in ChatGPT. These are actually these are autocomplete on steroids. They look back at a great amount of context, and then they do a forecast of what you're going to do. You've all seen the autocorrect, right, on your cell phones? Not autocorrect, but where they try to suggest to you the words that you use next in your sentence, and it's that on steroids. So, but what it can do is incredible. We're talking today, I think with David and Luke here, about the fact that ChatGPT, their pay model, can actually solve differential equations, which is really astonishing. I don't think that's a large language model, though. I don't see how it could learn that. See, if you give ChatGPT like an instruction on how to do derivatives, it isn't going to learn how to do derivatives. It only looks at the semantics. It doesn't look at the there's the syntax and the semantics, and it doesn't look at the actual deeper meaning of it. It just looks at the statistics of the placements of the words. So I asked it to write a limerick. It writes poems, too. Here's a limerick about AI Week. Write a limerick about an AI Week at Baylor University. Okay, at Baylor, the AI Week's bright with robots and data in sight. They'll discuss what's in store, text limits, and more at Foster, where futures take flight. So that was a nice limerick written by ChatGPT. It can write regular songs and poems. One of the weaknesses I found, and I'm sure they're going to fix this, is you can't tell large language models like ChatGPT what not to do. Do you ever tell somebody, don't think of a pink elephant, right? And, oh, you think of a pink elephant. So you can't tell these large language models yet what not to do. So I said, draw a picture of Times Square at night. There are no pink dancing hippos either on the street or on billboards. There are no dancing pink elephants, and pink dancing hippos. And so it couldn't ignore it. So it wrote. So I thought I'd give it more specific instruction. Do I think that ChatGPT and OpenAI can put a Band-Aid on this and fix it? Yeah, I don't think there's any doubt. But here's another one. Picture of a red Ferrari driven by a young lady with no teeth. The windows are down, doing a wheelie. The lady has no teeth. No teeth. There are no elephants in the picture. No elephants. I got 4 elephants, and the lady had teeth, but so did the car. Okay, so if you want to have some fun and you can do images with these things, try telling it what not to do. It doesn't know how to do that yet. So let me address some questions which are asked quite a bit. Can AI write music? No, it can't. AI is not creative. Say, for example, you want to write an AI program that generates Baroque music. What do? You get the works of Bach and Handel, and you train the neural network with that, and guess what it does? It generates music which sounds like Bach and Handel. It will not generate jazz. It will not generate music that sounds like Wagner. If you want music that sounds like Wagner, you have to train it with music that sounds like Wagner. So it is simply mimicking the data that's being trained. Can it write prose? If you've tried this, Adam here sits on the, the Honors Council, and this is where professors, if they suspect somebody is cheating, they bring this to the Honors Council. And there's been a lot of ChatGPT. We won't get into specifics, but there's been a lot of accusations. And I think one that he told me, he looked at a ChatGPT and they asked the student accused, they said, did you use ChatGPT? He said, no. And they looked at it and they said, what does this word mean? He didn't know what the word meant, which was really evidence that, yeah, he probably didn't write it. In fact, can it write prose? One of the interesting things about ChatGPT, by the way, and OpenAI, is they have basically used almost all of the fuel for training these high-level networks. The only place that they have to go now is places like Facebook and Twitter, but all of the great literature, a lot of the stuff on Wikipedia, and everything has been used to train it. Trillions of words, and they're running out of fuel. Noam Chomsky said, GPT is like high-tech plagiarism, and indeed it is. And because of that, it turns out, if you follow the news, there is litigation galore. Everybody is suing the AI companies. It turns out the New York Times filed a lawsuit against ChatGPT's OpenAI for using content that fell behind its paywall. It was using content behind the New York Times paywall in order to train ChatGPT. I just checked a couple of days ago. This is ongoing litigation. Reuters is suing an AI company, Ross Intelligence. One of the big ones is Getty Images. You've seen Getty Images a lot. If you have an image and it says Getty Image, if you use a Getty Image, you're going to pay them either voluntarily or in court. They are very litigious, and they are suing Stability AI for use of theirs. And they have some good smoking guns. Here was, for example, one that they found out. This was early AI, but can you tell what the smoking gun was that they used a Getty image? At the bottom right, you can see the Getty logo. It's kind of distorted, but yeah, they used it. This is another one. This is more modern. This is say, draw a picture of the Joker from the movie, and that's a picture of the Joker from the movie. Draw a picture of Iron Man. Well, it turns out that this is a copyrighted image from Marvel Comics. This is one of my favorite. They asked Bing for an Italian video game character. No mention of the Mario Brothers. Here's what it gave. So you can see there's no doubt that there is plagiarism going on here. There is different degrees of the plagiarism, but these guys have a very interesting case against these AI companies. It's going to be very interesting to see how this litigation plays out. So with that, I want to spend some time for Q&A, moderated by Dean Pack. But I just want to mention in general that AI and the stuff we're going through now with ChatGPT and these other generative models is something which is with us in the future. The smoke is out of the bottle. It's going to be used as a tool. It's going to be used in different places, and we're going to have to figure out how to use it. And I look back, and here are the different things which, when they came out, I went, wow, this is incredible. Things like Uber, like Google Maps. Google, what a miracle. Now I just take them for granted, right? I think that in 5 or 10 years, all of this AI that we have, like generative AI and such, is going to be just something that we have figured out how to live with. It's going to be disruptive, but I think in general, it's going to supply tools which make us all better. I think it's going to, technology frees people up. 2 generations ago, my grandfather was out in the cornfield plowing up weeds, okay? And now we get to come to a nice air-conditioned auditorium and listen to I was going to say an interesting talk, listen to an interesting talk. So we have all of these things which technology has provided us. This is what's going to happen with this AI. And certainly AI has, and technology has replaced things. The brick and mortar stores, Sears has gone down. You don't have any toll booth operators anymore. There's no travel agents anymore. So it's been disruptive. It'll continue to be disruptive, but it will continue to add things. So in summary, AI will never experience qualia, which is a type of sentience. It'll never understand. It will never experience emotion. I think these are obvious. I didn't even spend time on them, but they'll never love. They'll never have empathy, et cetera. Now they can simulate empathy. They can simulate emotion, but they are never going to actually experience, and they will never be creative. And it gets down to something, the humans are really exceptional. We're exceptional. We have wonderful quality, and it reminded me of the great verse from Psalm 139 that says, we are fearfully and wonderfully made. Just an incredible stuff that we can do, which is non-algorithmic. So that concludes my talk. Thank you for listening.
Thank you, Dr. Marks, for a very insightful presentation. So here now we have time for questions to Dr. Marks. So if you have questions regarding what he has presented or related to what he has not presented, please go ahead. Here's a question right here.
Can you explain why do the language models have such difficulty writing long passages of prose? They're trained on trillions of pages of novels and everything else.
Why aren't they consistent? Well, it turns out that if you go back, I think this is ChatGPT 3. ChatGPT 4 didn't illustrate what they did in terms of the details. But if you go back to the models, where'd you go? There it is. That they have 2,048 tokens. That's basically their memory for the basic vanilla large language model. That a token, by the way, is a word segment, but just think of it as a word. They have used 2,048 words. And so when they go back and they're trying to pay attention to what's happening, after 2,048 words, that falls off. And so I believe that ChatGPT 4 is even longer than that, and I do believe that they have some recurrence, which they're putting in for longer-term memory, but that's basically the reason, is that they only look back for a certain amount of time. Does that work? Okay. So yeah, 2,048 tokens is what they use.
Okay. Other questions? There's a couple here.
What do you think about AI for Excel modeling and things like that?
I'm not familiar with Excel.
Spreadsheets. Oh, no, don't worry then.
Okay.
Thank you.
What do I think about AI and Excel? You mean the spreadsheet?
Yes. Can they build a model if they have the proxy statements and then forecast or get summary of industry trends and
Well,
build?
this is interesting because Excel can currently do things like regression curves, and they can do correlations and all of this analysis of data. So it doesn't surprise me that they've put AI in terms of use of something for forecasting, for example, where you forecast data based on some sort of model. So I don't know much about the incorporation of AI into Excel, but they already have these statistical models. And some of the AI you can think as kind of advanced statistics, advanced regression machines, if you will.
I think about that can already be done in Excel, but to write the analyst report, like emulate the other analyst report, I feed you this and build me the graphs and generate insights.
Yeah. Oh, it can do incredible things. We have Mike Thompson in the back. Mike has done a lot of work on. He's an expert in prompt engineering, right? And you've done some incredible stuff in terms of getting reports out of ChatGPT, right? Yeah. So yeah, it can do incredible things. So you need to get together with Dr. Thompson if you're interested in that, because he's always looking for something else to do. So.
Okay. Bob, this was a great presentation. Thank you.
Oh, Larry. Yeah. Yeah. Thank you.
You know so much more about this than I do, so you persuaded me. Yeah, it's not going to happen. But that was pretty easy to do because I know virtually nothing about this. On the other hand, you showed some really smart people at the beginning
Yes.
who have positions absolutely opposite to you. And without getting into the logic of why this person may be right and this person may be wrong, can you get into the psychology or sociology of, let's take the folks that are wrong. Why can these brilliant people not see what you see? What prompts them to think the end of the world is at hand?
I think, Larry, it's because they live in a silo of materialism. They do believe that we are computers made out of meat. I don't believe that any of the people that I quoted have any idea of faith. They believe that that the feeling of love is just another feeling, like the feeling of indigestion or something like that. It's a more pleasant experience. But interestingly, there is, well, let's see. Blaise Pascal said that there's a God-shaped vacuum inside of every person that can only be filled through God. And since this is Baylor, and I can say that Pascal said that was Jesus Christ. Now, it turns out that everybody has this vacuum inside them. And there is literally an AI church. There is an AI, and if you go to Google and you put an AI church, you will see an AI church come up. One of the pioneers of this was a guy named Anthony Lewandowski. Anthony Lewandowski worked for Google Waymo, and he was recruited by Uber, and he was into self-driving cars. And he started the AI church, and what's the first thing you do when you found a church? You file for tax exemption, right? So he filed for tax exemption, and he wrote a little epistle to the IRS saying that he believed the AI is going to become more and more and more intelligent and eventually achieve a godlike status. Ray Kurzweil was asked, "Do you believe in God?" He says, "Well, not yet," which is a very interesting thing. So I think a lot of these actually come from the philosophical. What people have used to fill this idea, this longing for a God, and they have used this from a materialistic viewpoint in order to promote what they're doing. They're just thinking inside of the silo. And Walter Bradley, who used to teach here at Baylor, you knew Walter. He was deposed one time. It was about the adoption of high school books in Texas, and he was asked, "Are you a Christian?" He says, "Yes, I am." He says, "Well, why should we believe anything in science that you believe if you're a Christian?" Certainly you're biased. And his response, and I love this response, he says, sir, I'm not the one with the problem. You're the one with the problem. You live inside these little materialistic silos. And I believe that Kurzweil, Hawking was definitely not a theist. You live inside these little silos, and you're the one that restricts. Everything must fit in your silo. I, on the other hand, can exist inside your silo, but I can also think outside of the silo into things that God might have done in terms of some of these things that we talked about in terms of love and stuff. I think it was a Kurzweil that said, yeah, love is just another emotion. Or thought or thinking is just another emotion like lactating or something. It was really a ridiculous statement. So the short answer to your question is that, yeah, they're trying to fill a vacuum inside of themselves, and they will admit nothing outside of their little silo of materialism as I think a theist, a person that is theologically based can do. So that's the reason. You're right. It is philosophical. If you're a materialist, you have to believe we're a computer made out of meat.
Thank you for your talk. I'm wondering if you could define or maybe even operationalize the way you're understanding the concept of understanding.
Oh, of understanding?
Yeah, you make the claim that AI is incapable now or in the future of understanding.
I guess I would appeal back as it's not a proof, not a definition, but the Searle's Chinese room. It's very clear that he has no understanding of what's happening. For example, if he got a little slip in the door that said, what should we do? There's a thermonuclear bomb which is going to go off next door, and we want to do something about it. He would look at that, not understand what it was, wouldn't understand the context. He would get the answer, and it says run, but Searle would not get out of the room because he didn't understand what was going on inside the node. So therefore, I think that that's the best definition. And this is also very interesting. And I claim that we can think about thinking. We can understand understanding. But AI will never do that. AI will never think about thinking. It'll never understand about understanding. So we can go to that meta level, if you will. I don't know if I answered your question or not, but okay. I got one of these, which is good enough. Okay.
Here's a question here.
Thank you for your talk. I had a quick question about the model degradation section. When you just
model collapse.
Model collapse. When you described that, you were describing feeding one model's output into another model's input, or using a model's output to train another model.
Yes.
I was wondering, have there been attempts made to, instead of generating the training data, to have one model write or rewrite the algorithm itself that converts that training data into the model, that runs that training process?
Let me give you the obvious answer that in order for the computer program to do that, the computer programmer has to give it the wherewithal to do it. So it doesn't pass the Lovelace test for creativity. It still would do only what the programmer intended it to do.
Right. I was just curious if there had been any attempts made.
I don't know. You guys know anything? We have some AI people up here.
Or if it could be possible to train an AI on good algorithms to train other AI. Like in a training process, you have the what do they call it? Reinforcement.
Reinforcement learning?
Yeah. So if you could say, this is a really bad algorithm, and then this is a good one, and then somehow train a model to make better algorithms.
Well, first of all, notice who's combining the programs. The programmer is, right? So yeah, no, all of the creativity goes through that. Look, if you look back at the history of artificial intelligence, and by the way, Stephen Hawking and I think Elon Musk are concerned about AI writing better AI, about writing better AI. In the 1960s, you have Bernie Woodrow at Stanford doing something called the Adeline. In 1974, Paul Werbos invented error back propagation, which is used in all of the models that we hear about today. I forget when it was relatively recently, the convolutional neural networks were just incredible. They're the ones that are used in all the medical imaging and such. And then there was the generative AI, these fakes, these deep fakes that we see. And then more recently, understanding is all you need, which was the formation of the transformer. Notice that none of those were AI created by other AI. All of those were created by the ingenuity and the insight of a computer programmer. Some person that had I've heard it, Penrose called it the flash of genius. We have a flash of genius, something outside of the box. If you think of that old metaphor, AI can only think inside the box. It can only think of what it's been doing. We have the ability to think outside of the box, and thinking outside of the box is another way to talk about creativity. And so if there's going to be greater computer programs, and even Sam Altman, the head of AI, said that in order to make breakthroughs, we are going to need some new algorithm, some new insight. And that insight is going to come from human ingenuity and human creativity. And it isn't going to come from AI. And I know of no evidence where AI has created another computer program which violated the Lovelace test.
Great, thank you.
Okay.
Thank.
Okay, go ahead.
Okay. This is Rafe. So my question is, like, if I write a poem today by matching few words or compose some music, I'm not a musician, but compose something without understanding much, you will still say it's bad creativity, but it's a creativity. But AI can do it better than me, better than many of us. It can really compose very good poem, music, and so many things. Why do you still say that it's not creative?
Well,
Maybe
first,
it's not understanding, but still, when human is creating something without understanding, we still say it's creative. When AI is doing that, why do we say that it's not
well, see,
creative?
creativity is easy to define in mathematics and the science. I can say that the theory of relativity, that was creative. Quantum mechanics was creative. It's harder when you get to the arts because there are so many different factors which go into explaining what good art is. In the 19th century, and this is very germane to the answer to your question, is the music that was written by the AI, is it art? They used to have at the French opera, they would have claqueurs. And these people would be hired to sit in the audience, and after the performance was over, they would jump to their feet and they would go, bravo, no matter how bad the operation was. It became so successful, everybody started saying, wow, this must be good. So they started in clap too. And the reviews in the paper the next day were a lot better. And it got so popular that we get, that they started to unionize it. You had different claqueurs that were criers, you had laughers, and you actually had agents where you could go to the agents and hire a whole slew of claqueurs to come to your program in order to increase the popularity of it. So in art, in my opinion, I'm an engineer, okay? I don't appreciate art to the depth that I probably should. But I do know that the people that are popular in music are there not just because of the music, but because of their image. There was a movie out called Yesterday where everybody in the world forgot about the Beatles. Anybody see that movie? Okay, everybody forgot about the Beatles, and this guy came along, and he was the only one that remembered about the Beatles, and he started writing the songs, and all of a sudden he became really popular. That wouldn't happen. The Beatles were popular because of their promotion, because of their stage presence, because of who they were. And if you think of some of the performers today and you take away their stage presence, you don't get that. Art is in other words, it's hard in my mind to define what creativity in art is. I do stand by my idea that if you want to create Bach, you feed it a bunch of Baroque music and it generates stuff which sounds like Bach. And so I wouldn't say that that's creative. So I've seen nothing outside of that box. Creativity in the arts and in science and mathematics, that's easy. You prove Fermat's last theorem, for example. Whoa, that's really creative, beyond a doubt. But stuff in art's a little bit more fuzzy. I had a big long talk with a guy that was I think he was called a broker. He went out and he got all sorts of art to go to a museum, and man, we could not communicate. He just says he knows it when he sees it. I showed him a Chat GPT image. I said, "Is this art?" And he says, "No." I says, "Why?" He says, "It's too sharp. It was too in focus." I would have never got that. So I don't know if that answered your question, but again, yeah, creativity in art is much more difficult to define.
I think one of the things
it
that we
has
have to,
it has to do a lot with clackers.
I think one of the things we have to consider is separating capabilities from understanding or capabilities from consciousness. So what Dr. Marks is advocating, that they might have capabilities, but they really don't have that understanding. Right? So we'll go to this question over here.
Yeah, I had a question about the Lovelace test. It's not. It seems like a little bit of a fuzzy definition in the sense that, okay, intentionality. So if the programmer intended to create AGI and he succeeded, then he would fail the Lovelace test, and that seems like maybe a problem. And so,
Well,
secondly, if by intentionality you're narrower than that, then it seems quite clear that ChatGPT and other sorts of programs do all sorts of things that their authors, that the programmers never intended directly or specifically, because they're general sorts of programs. So that it's not that the programmer knows how it's going. In fact, one feature of neural networks in general, even the simplest ones, is that the programmer often has no idea how it's going to respond to a given input, and so you can't say that they intended a given response because they can't even predict it. So I was wondering if you could sharpen the definition
sure.
of,
Let me
of
give it a try.
intentionality on the part of the programmer there.
Exactly. No, that's a great point. I think everybody that writes a computer program might be, not everybody, but many times when you write a computer program, you'll be surprised at the output. It won't be something that you expected. Yet you can go back and you can look at the code and you can say, "Oh, I see why it did that. That is in the code." I did some work on swarm intelligence where you had a bunch of modeling insects. And one of the things that we found is that there was this very interesting property where if there was prey and there were two predators, these predators would move in, and it looked like they had learned to corner the prey in order to get it. We looked back at the code and we said, "Wow, that's exactly something that we allowed." We were surprised, and so you're going to be surprised at some of the outputs, but it doesn't necessarily equate to creativity. So I don't know if that satisfies you, but hopefully the idea of surprise is something that indeed can happen in a computer program, but surprise is not creativity, because many times when you dig deep down and look at the origin of surprise, you go, "Oh, wow, that was in there," and you didn't realize you put it in there. It is not beyond your explanation.
Other questions?
Have I worn them out?
Well, let's give Dr. Marks one more round of applause
Thank you.
for his talk.